All right, in this video we're going to talk about what are called redox reactions. Redox reactions. And so let's take what we learned in the last video where we were assigning oxidation numbers. Here's a very simple single replacement reaction. Lithium reacts with sodium fluoride, single replacement, so these two guys switch places to make lithium fluoride and sodium. Okay, +1, -1 off the chart, +1, -1 off the chart. Sodium and lithium are zeros when they're by themselves. Now, balance it, one lithium, that's good. Sodium, one sodium, got it, fluorine, so I don't even need to balance. When we assign oxidation numbers, I know that guy is 0 and that guy is 0 because they're just elements. So if I follow the rules for oxidation numbers that we did in the last video, we know that sodium's in the first column, so it's +1. Fluorine must be a -1, and there was a rule, fluorine's always a -1. Okay, so it works like this, great. And we said, I alluded to in the last video that something really weird is happening with redox reactions, and here's what's happening. In first year chemistry, we basically do it like this, and we say single replacement, replace your partners, you got it, no big deal. But really what's happening is some things are changing charges. The first thing I see is fluorine doesn't. Fluorine's a -1 there and it's a minus there. Lithium goes from a 0 to a +1 on the other side. It changed charges. Sodium went from a +1 on this side to a 0 on that side. Whoops. The only way that can happen is by a movement of electrons. Okay, quick reminder. Lithium is element number 3, and if lithium's element number 3, it had 3 protons, 3 electrons, it's neutral. We know how to do that. So that lithium right there is neutral charge. Now, when I take those 3 electrons, and in middle school you learn to draw simple atoms, if this is a nucleus and this is the first ring, we know the first ring holds 2, and in this case that means the second ring holds 1. Okay? Then what is happening is to have a full outer ring, if it throws this 1 electron away, then that ring is completely gone, and when it does that, you have 3 protons and 2 electrons, which is a +1 charge. Okay? That +1 charge happens to match its oxidation. So that's how it went from here to here. Now how did it do that? It threw away an electron. Electron broke off. So this is really a different way of showing what we already know to be true. To go from here to here, you have to lose an electron. Now, what happens with sodium with a +1 to get to a neutral charge? Well, quick math says if I have +1, if I had a -1, 1 electron, then that would become neutral. So I want you to notice what's happening. In this reaction, one guy's throwing away an electron and the other guy's gaining an electron. First, you have the law of conservation of mass. The law of conservation of mass that says mass can neither be created nor destroyed. That's why in first year chemistry, if they didn't equal, we'd put the big coefficients in there until we had equal numbers on both sides. But the law of conservation of mass also counts for electrons. You can neither create or destroy electrons. So what's happening here is this. I'm throwing away 1 electron, but I'm gaining 1 electron. So overall, did I lose anything or gain anything? No, it just went from one place to another. It went from one element to another. This is what is called a reduction reaction and an oxidation reaction. They mix those two words together and they get what we call redox. So one of these is an oxidation and one is a reduction. And so these reactions become very important because in reality what's going to happen in a few days is we're going to not only talk about where the electrons pop off and they're taken on to something else, but if I can get those electrons to run down a wire, I have electricity, which means I have power, which means I have a new source of energy. And you and I live off of this electrochemistry that's happening all the time every time you start your car. That big battery on your car is an electrical device that comes from the hydrochloric acid and the terminals inside that battery. I have a movement of electrons from one place to another, and we're going to learn how to do that. So let's deal with redox reactions here for a minute. Now, a couple of definitions. Oxidation, reduction. Oxidation is the losing of electrons. Reduction is the gaining of electrons. So you're going to have one reaction that's going through oxidation and the other one that's going through reduction. Now, they're happening at the same time. That's why they mix the two words and call it redox. So as one is losing, one is gaining. Now, it's really hard to get it all straight, so here's a little acronym to help you. Oil rig. Oxidation is losing. Reduction is gaining. Pause the video and write that down. Oxidation is losing. Reduction is gaining. All right. Now, what I want to do is I want to take the example that we just had. Take out these words here for a minute. So let's see what's happening. Now notice how the arrow is going from left to right. So we're talking about this reaction going this direction. We're going to talk about this direction going this way. What is lithium doing going from here to here with its electrons? It's losing it. So if I deal with oil rig, this is my oxidation. What is the sodium doing going from here to here? It's gaining an electron. So that's my reduction. Did you catch that? Lithium is losing an electron. That's your oxidation. This is your reduction. Now, these are what together, when you do it like this is what are called half reactions. Because it's too hard to deal with them at the same time, so we split them in two so that I can see what this one's doing and I can see what this is doing. This is a very simple one. I'm going to show you a more complex one here in just a second, but it's called half reactions. So I need to know how many electrons are being given off by one and make sure that they're the same amount taken in by the other. So we have to be careful as we go along and we do that. And it's a lot easier if we do it as half reactions and evaluate each one as we go along. Okay? So let's look at a different one real quick. Okay? So the first one we did, that first reaction, that was what? Single replacement? Okay? Let's look at a synthesis reaction. Synthesis reaction. Okay, so I have sodium metal with chlorine gas to produce sodium chloride. That's an element. That's a diatomic element. Remember, there's 7 of those on the periodic table. I'm just going to give you a hint. For some of it's been a while since we've seen it. These 7 right here are all in pairs when you find them by themselves. N2, O2, F2, Cl2, Br2, I2, and then H2 over here. There's 7 of them. 1, 2, 3, 4, 5, 6, 7. These 7 are in pairs when they're by themselves. Only when they're by themselves. Okay, so sodium is right there. He's not one of those. Chlorine is one of those 7, so it's Cl2. Where did the 2 go? Well, when you put them with a partner, I know that sodium's +1 because of the first column, so I'll put that sort of close. Sodium's +1. Chlorine is -1. So there's my formula. So I know that's correct. Okay? First thing, is this the whole reaction? No, and here's why. 1 sodium, 1 sodium. Got it. Law of conservation of mass. 2 chlorines, 1 chlorine. So that means I need a 2 there, which means I need a 2 there. So let me check my work. 2 sodium, 2 sodium, 2 chlorine, 2 chlorine. Now this is my reaction. Got it. Perfect. Now, let's assign oxidation numbers. I know that guy's 0 and I know that guy's 0. How do I know that? An element, and this is the element chlorine. Okay, so I got to be careful here. Chlorine is a -1 when it's with somebody else. Is it with somebody else right there? No, it's just chlorine. It happens to be found in pairs. They're in twins. Okay, so that's neutral. What about sodium here? +1 and chlorine -1. So let's break it into the 2 half reactions. I just start with the first guy that I see. Sodium is going to go to sodium +1. That's what I see happening. 0 to a +1. Sodium to, now, this has a 2 here. There's 2 of them. Okay, so, but I'm going to deal with that in a second. So what happens when this guy goes there? He has to lose 1 electron. I can always check myself. +1 minus 1 equals 0. Always check yourself. All right? So forget the big numbers for a second. For sodium to go to that sodium, sodium is 0 to a +1. Got it. Now look at the whole reaction. It says there's 2 of them. So if I have two of those, what does that mean? I'm going to have 2 of those floating around, but that also means how many electrons? I had 1 electron given off from one guy, 1 sodium, and then the other one gave off. So 1 sodium gave 1 electron, 1 gave another. So let's look at the other. Cl2 is going to go to Cl. That's a 0, and that's a -1. Now, there's no number there. Okay. Oh, there's 2 there. So that means to get Cl to a -1, it gets an electron. So it had to get 2. So 2 electrons here. So -2 plus 0 is -2. See the math that I did? -2 equals -2. So here's what we're doing. You know how you balance all this reaction in first year chemistry? There's 1 sodium, 2 chlorine, so I put a big 2 there. You have to balance your half reactions. Okay? So notice how when I started with 1 sodium and 1 sodium, and I figured out what does that guy have to do? That guy had to lose 1 electron. Now, going back to the full reaction, there was actually 2 sodiums there that became 2 ions, which meant there are 2 electrons. And so you can see that that is balanced. How do I know? Watch this. 2 sodiums, 2 sodiums. Now check my overall charge. +2, -2 equals 2 times 0 is 0. One more time. +2 plus -2 equals 0. So let's check this one. This is 0. There's nothing to multiply by. -2 plus 0 is -2. This whole side's a -2. That whole side's a -2. Do I have equal atoms? I have 2 chlorines here and 2 chlorines. So I have to balance atoms and charge. I have to make sure it all is working out. Okay? Now, I got it. I did it real slow on this one. Now what I want to know is half reaction, half reaction. Is this oxidation or reduction? Oil rig. Oxidation is losing. So this is my oxidation. Reduction is gaining. So this is my reduction. So the big skill is being able to take the reaction, break it into its 2 half reactions, balance that half reaction inside of itself, balance the half reaction within itself, and then figure out who's oxidized and who's reduced. Here's the really cool part. Gaining 2 electrons and I'm losing 2 electrons. Everything that I'm losing, I'm gaining. So I know my whole reaction balances out. Not just with big numbers, but with charges also. So I'm taking into account overall charge and taking into account the atoms as well. All right, let's try another one. What happens if this reaction were turned the other way around? NaCl decomposition. When you break it in half, you get sodium plus chlorine. Now we know when chlorine's by itself, it's in pairs, right? +1, -1 off the chart. That's neutral. That's neutral. +1, -1. Got it, okay. 1 sodium, 1 sodium. 1 chlorine, 2 chlorines. So I need a 2 there, which means I have 2 sodiums. So I'm going to walk through the process again as if we haven't seen it at all. So I want to walk through the whole thing. Okay, so here it is. I see that sodium +1 is going to go to sodium that's neutral. Now, how do I do that? I have to add 1 electron. So remember, electrons are always negative, so look at your charges. A -1 and a +1 equals 0. So I got my charge to work. Now, do I have everybody accounted for? Well, there's 2 sodiums. So if I have 2 sodiums, it's going to take 2 electrons to make 2 of those. So I balanced my atoms. 2 sodiums, and my charges. 2 negatives, 2 positives, so -2 and +2. That side is 2 times 0, which is 0. Notice how that equals each other. So both sides are equal. Okay? Now, chlorine, on the other hand, is a -1. And chlorine is going to go to Cl2, which is neutral. Now, I see there's 2 chlorines, so I have to have that 2. That's without a doubt. How can I get... Man, what is happening? I see that this one is gaining. This one tends to tell me that I'm going to lose over here, because this is the negative side. If I had 2 electrons, check my math, isn't all that -2? All that together is -2, should equal 0 plus -2. They do equal. What happened if they didn't? I'm doing something wrong. See, if I accidentally put a 1 there, -2 equals 0 and a -1. Those don't equal. So I have to take those in consideration and be very careful. Okay? So I'm learning how to do the half reactions, balance the atoms and the charges. Now, which is the oxidation and reduction? Let's look at this one. Oil rig. Okay? Which one is losing? That is this one. This is oxidation. So this is the reduction. Hint, be careful when you pick. You're going to always have one. You will never have 2 reductions. You will never have 2 oxidations. You're going to have an oxidation and a reduction. Why? If one is losing, the other one's gaining. Why? Because they're giving them to each other. That's what's happening in this reaction. We're just going to try to harness that electricity, those electrons into electricity. Okay? So let's try another one. And when we go through them, it takes practice. Boy, I've done them a bunch, but it's so easy to struggle with it. Carbon is going to react with sulfur to produce carbon sulfide, carbon disulfide. Okay, that's a weird reaction. Okay, so let's check some things. By itself, neutral. By itself, neutral. If they gave me the formula, this must be right. So let's check something. How do I know some charges? S. Well, I know that S is there. And carbon, what is happening? Well, sulfur, the closest thing I know is it's probably a -2. And if that's 2 of them, -4, so this guy's a +4. See how I got that? Now I'm going to do something really tricky here for a second. What's the oxidation number of each sulfur? -2. -2 twice is -4. Did you catch that? 0 charge by itself, 0 charge by itself. They just gave me this formula, and so I had to pick it apart. Sort of like we did the polyatomics in the last video when you had something like this. Oxygen's always -2. 3 of them, that's a -6. If it has to equal -1, then nitrogen's a +5. Okay? So I had to deduce it from that. Well, all they gave me the formula carbon. I needed to have the oxidation of carbon and the oxidation of sulfur. The only thing I could get close to is sulfur's a -2. So if sulfur's a -2, yeah, there's its oxidation number. Twice on this end, -4 means a +4 because it had to equal 0. Now, this number plus this number doesn't equal 0, but together that makes -4, doesn't it? Okay? So let's see what's happening. Carbon is going to go from a 0. Carbons go from a 0 to a 4, +4. Wow, how do you do that? Ooh, you missed a step, Mr. Kelly. Why? 1 carbon, 1 carbon. 2 sulfurs, 1 sulfur. Whew, almost messed that up. Okay? Carbon's going from a 0 to a +4. How do I do that? If I add electrons on there, is that going to get me to a plus? No. So what's happening? I have to have 4 electrons there. 4 electrons, so +4 and -4 equals 0. That's pretty easy to understand. I see that sulfur's a 0, and sulfur's going to go to a -2. Each sulfur's a -2. Now there's 2 sulfurs there, and there's 2 sulfurs there. See, 2 sulfurs, 2 sulfurs. What? That's a 0. That's a what? -4? How can I get those to equal by adding electrons? If I had 4 electrons here, does that work? Let's check my work. 1 carbon, 1 carbon. 0 total charge on this side. +4 -4 equals 0. That one is correct. Charges, that's -4 on this side. That's a 0. 2 times 0 is 0, plus a -4. They do equal. So do both the half reactions take care of the law of conservation of mass? Yeah, they do. Which is oxidation, which is reduction. Oil rig, oxidation is losing, so this is my oxidation, and this is my reduction. First thing I want you to see, the first line is not always oxidation. It might be. The last one, reduction, was at the top. Every once in a while I have students like, well, the first line you always write is oxidation. No, you have to look. It's losing electrons. Oxidation, reduction. We're doing redox reactions. More specifically, we're doing half reactions. And so you're going to try these more specifically with a lot of different reactions. It'll take some practice, it'll take some time, but you can do this. Redox reactions and half reactions.